Do you guys want to make the announcement? Okay, everyone, we're going to start the lecture. It's 12:30, and your SI Pass leaders want to make an announcement, so I'm going to just keep the class going.
Hi, everyone. So, a week from Friday is your first exam. Raise of hands, how helpful would it be if we held an extended session next week?
So that would be a session that's like 2 hours instead of like the normal 50 minutes.
All right. So we'll send more information out later this week once we figure out what days we're going to do the extended session on. I'll hold an extended session, and Sydney will also hold an extended session. So keep looking at your email for that. Thank you.
Okay, and as I told you guys, I'm going to send your SI Pass leaders previous homework, previous exams, and quizzes, and also I'm going to send them your basically exam for this semester to them too, for them to solve really similar problems. So if you can go, probably you'll do better on the exam because they'll solve problems for you that are really similar to the exam. And if you couldn't go to any of their sessions, just email me. I schedule a tutoring session for you. So basically do the same thing that they're doing. Does that make sense? Any questions about SI Pass or tutoring? And again, I have my office hours right before the class, and I have my office hour for the other class, like 10:30 to 11:30, and most of the time, a few students, if any, show up to my office hours, so you're welcome to stop by 10:30 to 12:30, not only 11:30 to 12:30. And if you cannot make it to the morning sessions, I advise you to just email me, and before your exam, I probably include more office hours, but since you have so many SI Pass sessions and you're welcome to email me, I feel like email me and schedule a session. I think we should be good on like office hours and like tutoring sessions. Again, a reminder that we're mandated to wear masks, and just make sure to have your masks fully worn so students feel comfortable sitting next to you, and we won't be having any issues. Okay, first, I want to talk to you guys about like homework assignments and quizzes in this class. So I know as a fact, some of you may have like misperception about like my policies, or you talked to a student last semester and then they told you, you can just like skip homework, and then email her and say that, you had a family emergency or something, just talk with her afterwards. So last semester, I was really lenient towards like homeworks, basically they didn't have homeworks, but like quizzes, exams, and students, I was working really hard with the students, and then basically whatever they were telling me I was doing because they had an instructor change. And it was a really tough semester for them, so I was accommodating everyone. So this semester, I'm teaching the materials myself from the beginning. I told you my expectations, and I had a quiz from my expectations, right? I told you when are the homeworks due, and you said most of you knew that Wednesdays you have your homeworks due. So now if one of you, or some of you email me that after the fact that I missed the homework, can I do a makeup? The answer is no. Because I communicated with you my course expectations, okay? But still, I have some students that they didn't do quiz 1, or they missed the homework. And they emailed me and explained to me that they had like, family emergency, or they couldn't do it. And you realize that if I make an exception to one student, I should make that, exception for all of you, because there are like some students that they did quiz 1, although they weren't prepared to miss the deadline. So if they get 20 out of 40, and now I provide opportunity for another student, and they get 38, it's not fair. Are you following what I'm saying? So for that matter, and to accommodate this just this time, I'm going to have like a makeup homework 1, makeup, if I can manage this to write, okay, makeup for homework 1, makeup for homework 2, makeup for homework 3, and makeup for quiz 1. And if you missed, 2 of them or 3 of them, or if you weren't happy with your grades, again, because I cannot just make an exception for one student, I have to give all of you the opportunity. So if that's the case, first of all, email me and tell me which homework or quiz you want to retake, okay? And the time would be Friday, 4 to 5 p.m., or if you're taking multiple ones, like more than that, depending on that. But my focus is quiz 1, but if you miss other ones as well, this Friday. And I think this room would be available. I'll check with Deb. If it's not available, I'll update you next session. But this is only for these homework assignments and quiz 1. From now on, if you cannot make it or like finish homework 4, you have to let me know in advance. I had students, that they had COVID. They missed several sessions of the class and they communicated with me beforehand, and I gave them like makeup homework 1 or like makeup quiz 1. So that is fine, but you have to communicate that with me in advance, not after the quiz is due. Does that make sense? So from now on, if you miss it, for quizzes, you have like at least 9 days to accomplish that. For homeworks, you have at least like Sunday, Monday, Tuesday, Wednesday. You have 4 days. So don't put it like the last day, just take it early, okay? So from now on, if you miss a quiz and then email me that you had technical difficulty, you had like family emergency, afterwards I won't provide makeup opportunities. The reason is that basically, if I just do makeups, I cannot progress with the course. I just should be writing makeups and then proctoring them, and it takes lots of time and it's not efficient, okay? Are we clear about this? So how many of you would like to retake homework 1? How many of you want to retake homework 2? Okay, homework 3? Quiz 1? Okay. So make sure to email me so I know how many I should print for each of them, okay? And as I mentioned several times, the only thing that I care in this class for you is for you guys to learn. And as I said, when you learn, there is no way that you get a bad grade in this course, and you'll see, okay? So that being said, okay. Now I'm gonna go to the presentation that I prepared for our lecture. Insert. And like Thursday. But please, so I have this open, I guess, 4 to 6 for both days. Can anyone not make it to any of these times? Good? And again, you can communicate things with me. Just email me if you have like concerns. The only thing that I don't want is that you miss something and then just expect me to accommodate you after the fact, okay? And again, if you want to take any of these, just email me so I know how many I should. Okay, here, email me 6. So as of right now, if you go to Canvas, you can see your overall score in this course based on homework 1 to 3 and quiz 1. So I just did, some research, and I realized that 16 students as of right now, they're getting an F. 18 have D, like 25 C, 47 B, 18 A. It means that half of our class are A's and B's. The other half are kind of like, whether failing or like D or like low C. So I should also want you to remember your homework assignments and quizzes on Canvas are like open book, open note, yeah, and also like open resources. So if you cannot get a good grade having all the materials in front of you, chances are, you cannot do well on your exams that have like much more points. So I encourage you, take the course more seriously. And as we these chapters are like easiest. And as we go along, it becomes more complicated and it needs your devotion and kind of attention, okay? So for each lecture that we have in the class, 55 minutes, or 50 minutes rather, you should study 1 hour at home. And I know some of you are working, some of you have several courses, but if you cannot devote the time, and if you think, you cannot study well, so I know, yes?
I can't make either of those times. Would it be possible to have it uploaded onto Canvas and like reopen on Canvas?
No, because I want that to be closed book, closed notes. So what about Wednesday? This is kind of like last semester, repeating. And I had like, last semester, I just was like doing makeup, homework and makeup exams all the time. And I couldn't eat lunch or like go to the restroom, and it was just like really disastrous. That's why I don't want that to occur again. What about Wednesday? Wednesday at 4? So what time does it work for you?
Around 6.
Okay, would Thursday at 6 work? Okay. Thursday at 6. I encourage you to drop the course because I care about you. I don't want you to have like a bad grade, in your GPA. So whether start, studying harder, and again, right now, as you saw, you can make up for everything that you did bad. You can go to your SI class leaders, you can talk with me. I scheduled one-on-one tutoring sessions with you, and I have like already some students that made that point, yes.
Some of us have labs on Friday during that time for the
Okay, so what day would be, for students that cannot make it like Friday at 4, what about Thursday at 4? Can you make it? Okay, so I guess I'll just add this. Okay, so going back to this, February 18th is the deadline to withdraw from the course, and I don't want that to happen because I firmly believe if you just study the lectures and ask me questions or schedule tutoring, I'll do my best to make sure that you get a good grade in this course. But again, if you don't have the time, if you don't want to, again, I don't want you to have like a bad, grade and my, course, lowers your GPA. So I recommend, if you think that you cannot devote like 3 hours per week outside of our class time and quizzes and like homeworks, I think that maybe you should consider that. Okay, now I'm going to talk, first of all, any questions about whatever that I said? Clear? Okay, so last session I gave you a question at the beginning of at the end of the class that when I refer to gold, what could I potentially be referring to? Select all that applies. So when I say gold, can I be referring to a molecule? Can anyone tell me why, yes or no? Anyone? Can everyone see gold in the periodic table? So it's like above RG here. Atomic number 79, that is gold. So it's in the periodic table. So what is it for sure among these options? Element, because this is the periodic table of elements, right? So it is element for sure, so this is kind of correct. It's an element. What about atom? Can it be, gold? If I have like a gold ring or gold, something made of gold, can it be an atom when I say gold? What's that?
There are atoms of gold.
Exactly. Do you remember that we said matter ultimately they have like, they're made of atoms. So atoms are building blocks of all matter. So a golden ring has also atoms. So gold atoms constitute elemental gold. Does that make sense? So this is also can be the answer. What about substance? So you see, being said, I can be, referring to an atom or an element or a substance or matter if I had them here. But gold, elemental gold, is not a molecule. Okay? And when we progress with the course, I explain more why it's not a molecule, but we said molecules are like, atoms that they're bonded together with like chemical bonds or covalent bonds, right? So when we progress with the course, I tell you that gold atoms, they don't have covalent bonds between them, okay? So it's not a molecule, and gold is not a compound. Because again, they exist like as gold atoms. They're not bonded together by covalent bonds. And it's not a mixture. Okay, you have really similar question in your homework 4. So hopefully you can get that right. Next, so all that. Also, one of your friends, sitting there, asked about alloys in the 2 sessions ago. And I told you that alloys, they're a mixture of 2 metals, 2 elements, right? So if you have an alloy, you cannot distinguish the metals. You cannot see which one is which, or like, it's not like kind of like water and oil mixture that you can see water, you can see oil. You cannot distinguish them. So what would alloy be between these options? Exactly, homogeneous mixture. So, and most of you thought it's a compound. It's not a compound. H2O water is a compound because you have like, 3 atoms that they're bonded together with chemical bond. But copper and zinc alloy, they're just like 2 elements, or like 2 substances mixing together, right? So it's just a mixture. And since you cannot distinguish them, it's like homogeneous mixture. So the answer is like homogeneous mixture. So if I tell you what is this and this alloy, when you see alloy, the answer is homogeneous mixture. And this would be one of your quiz or like homework questions and most likely your quiz and exam. Any questions? Good? So, okay. Again, I have it here. So I told you that here we have gold, right? It can be an atom. Kind of like, not, this is kind of like, if we consider just one atom of gold, it can be like elemental gold, right? But elements are also pure substances, right? So gold can be, when I say gold, I can be referring to pure substance. And by the same token, you can see that pure substances are also matters, right? Because as you remember, a mixture is composed of different substances. But gold only has one substance, right? It's like elemental gold. Does that make sense? This slide here, and the reason is that if you don't know this slide well, you'll be having problems throughout the course because this is kind of like the building block of this course. So now you have the slide in front of you, so that's why now I dare to ask people, because you basically can just like look at the slides, look at the slide and give me the answer. So any volunteers that tell me what is matter? Yes?
Building blocks of all matter, any substance composed of atoms.
Any substance composed of atoms. Yes, that's one way to put it. Yes? Exactly. So this is like the general definition. Anything that fills space and has a mass, we call that matter. So is light a matter? Right? It doesn't take space. Okay. And what about element? Yes.
It's a substance that cannot be broken down into similar substances.
Exactly. So if I tell you, again, like gold, I cannot reach it, but you get the point. If I refer to gold, we cannot break down gold and then have silver atoms through ordinary chemical reaction. Okay? What about compound? Anyone? Yes?
A compound is a substance composed of two or more elements in a fixed definite proportions.
Exactly. And remember, when I say water, H2O, we always have two hydrogen atoms and one oxygen atom. We cannot have like HO, and we call that water molecule. It's always like fixed, proportions. What about mixture? Anyone? Mixture? Yes?
Compound is different substances that are not completely tied but simply mixed together.
Exactly. So this is the difference between compound and mixture. Mixtures, we have like different substances that mix them together. And if you can see the constituents, if the composition is the same throughout, we call that homogeneous. If the composition is not the same throughout, we call that heterogeneous. Any questions? Again, these are really important and I cannot emphasize enough. So if you have problems with these, make sure to study them and ask questions from me or like your SI path leaders. And this is kind of like, I can say with confidence, this is the most important thing in this course. Periodic table of elements that I'm going to give you in the exams, and you're going to use that to answer most of the questions that you see. And we learned the definition of elements, and we're going to talk in more detail about periodic table in chapter 4. What I thought that is really useful that I start making you familiarize with periodic table, because if you know this really well, you'll do really well in chapters 4 to 10. So the first element in the periodic table is hydrogen, is the lightest element. And when I talk about atoms constituents, you see why that is. Okay? So as of right now, remember that hydrogen is the lightest element and is a gas. Okay? And we have like different periods or rows in periodic table, which is like basically, how can I do this? Maybe I do highlighting. Okay. So this is like the first row or the first period. Okay? This is the second row or second period. This is like the third row. Okay? 4, 5, 6, 7. Okay? And these guys are like part of here, but we don't have to worry about it for now. Okay? So if we have like horizontal lines, we call them rows or periods. And this is something that I always ask in exam. So make sure that you know the horizontal lines, we call them rows or periods, okay? And the vertical ones, we call them groups or families. So this is group 1, group 2, and we have like 2 different types of groups that I'm going to talk in more detail, but as of right now, know that we have like main groups that we denote them with A's. So this is group 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. and we call them groups or families. So the vertical lines, the vertical ones, elements in periodic table, we call them families or groups. Any questions so far? Is this clear? So what I'm going to do now, I'm going to introduce you with the first. So I talked about hydrogen, which is a gas, okay? So it's like in the first row and first group of periodic table, okay? Other than, when we call these families or groups because they have the same characteristics. So, but we have like an exception here in group 1A that all other elements, they are metals. But hydrogen is a gas. Okay? So today I'm going to ask you to remember lithium, sodium, potassium. These are 3 metals. And when we progress with the lecture, each session, I'm going to ask you, what was the first metals that I mentioned? Lithium, sodium, potassium. And remind you that lithium, sodium, potassium are metals, but hydrogen is a gas. Okay? Any questions so far? And again, this is from your chapter 4, but since this is really important, I'm going to start, talking about it, from this session. Okay? So what was the 3 metals that we talked about right now? Exactly, excellent. Okay. So the next section, or chapter 3, is about properties. Can anyone tell me what is the definition of property? And you have like the definition here too, but you probably heard the word property before too, right? Did anyone heard of property before? Can anyone tell me what do you think is the definition, or like based on what you see in the word? Yes?
Properties are just distinguishing characteristics of different stuff.
Exactly. So if you have like different matter and you want to distinguish them from one another, you can use properties, right? And again, I have like everything, since I didn't make the textbook mandatory, although I encourage it, but since it's not mandatory, I have like all the definitions that I'm going to ask you in the slides, and I'm going to emphasize on them. So you don't have to worry about not having the book. The characteristics that distinguish one substance from another are called properties. So can anyone tell me, and again, I have the answer here too, but probably you can just like listen to what I'm saying and then tell me the answer. If you have like alcohol and then water, right, in 2 cups, and I give that to you, and then I ask you which one is alcohol, which one is water. How can you distinguish that without tasting it? Smell, right? If you smell, you can see the difference. What about gold and silver, for instance? What's that?
They look different colors.
Exactly. So these are all different properties of these substances, right? In general, in chemistry, we categorize properties to 2 different types, chemical and physical. So what do you think, do you think smell is a physical property or chemical property? Physical, right? And we're going to talk about their definition so it can be easier to distinguish. So, physical property is a property that a substance shows without changing its composition. And in the next slide, I give like more explanation from your book. And chemical property is a property that substance shows with changing its composition while changing its, composition. For instance, first of all, again, I have like, definition here. So, if you have like gasoline and you smell it, it doesn't matter if you have like a small amount, you know, or like bigger amount, right? It smells, I mean, probably the smell would be more pronounced, you know, if you have like more of it. But again, it's not like that. If you have a small amount, it smells like something else, right? It would be the nature of the smell would be the same. And also, when you smell something, its composition won't change, right? In other words, it's a physical property. Gasoline does not change in its composition when it exhibits its odor. Sorry. And the atomic or molecular composition of a substance does not change when the substance displays its physical property. For instance, you know, again, another example. The boiling point of water is 100 centigrade degree. When water boils, it changes from liquid to gas, but it's still water, right? So if you have H2O and the water evaporates, you don't get H3O, right? It is still the same composition, just the water phase changes. Does that make sense? Good. And physical properties include odor, taste, color, appearance, melting point, boiling point, and density. Any questions? And this is something I always ask in the exam. Which one of the following is not a physical property? So as long as you know physical properties, you should be good. Questions? And you know, if sometimes when I'm talking, if you have questions, just like feel free to raise your hand, you know, and interrupt me. That's totally fine. What physical change? Okay. Now, chemical property. Again, you know, a chemical property is a property that when substance shows that, you know, its composition changes. For instance, if I have a piece of wood and I burn it, right, the property associated with that would be flammability. You know, the ability of a substance to, you know, be burned, right? So when I burn something, or like wood, it changes from wood to ashes, right? The chemical composition changes. Or if I have like iron, and then it oxidizes or it becomes, it turns into rust, I have iron and it changes to iron oxide or iron trioxide. And when we progress with the course, you learn how to write these compounds, you know, or like rather these substances. But as of right now, just know that the composition changes when we have chemical properties, okay? Again, a chemical property is one that the substance displays only throughout changing its composition. The flammability of gasoline is a chemical property. Gasoline does change its composition when it burns. The susceptibility of iron to rust is a chemical property. Iron must change into iron trioxide to display this property. Chemical properties include corrosiveness, flammability, acidity, and toxicity. Any questions? Good? Okay. So now about physical change. Now we talked about physical properties and chemical properties. Now we want to talk about physical change and chemical change. Okay? So in a physical change, matter changes its appearance but not composition. Again, remember the boiling or evaporation example? If you have water in liquid phase or water in gas phase, both of them are still water. The chemical composition is H2O, right? Your chemical composition does not change. Only the phase changes, right? The appearance changes. But not the composition. Composition doesn't change. And here, when ice melts, it looks different, but its composition is the same. Solid ice and liquid water are both composed of water molecules, so melting is a physical change. And a physical change results in a different form of the same substance. and vaporization is a physical change. Again, I'm writing all of these things, so I'll be more confident to ask you questions and then make sure you know these things. Any questions? Good? Physical change? And again, here I have like an example. So all of the phase changes are physical change, right? And here we have like, I took this image from like this website. So if you have like solid changes to gas, right? Do you know what we call that? Exactly, sublimation. Or if you have gas turning into solid, right? The position. Or, gas turning to liquid, condensation, right? Or like liquid turning into gas, evaporation. And melting, solid to liquid or liquid to solid, solidification. So all the phase changes are like physical changes. Okay? Questions? Now, can anyone tell me, based on what I said about physical change? Now, can anyone define what is a chemical change?
The composition changes.
Exactly. So in a chemical change, matter does change its composition. And you see, probably now you're kind of familiar with my question asking style, right? My test style. I'd probably tell you, in a chemical change, matter does not change its composition, true or false? False, right? I said in a chemical change, matter does not change its composition. It does change its composition, okay? So that's the difference between physical change and chemical change. Copper turns green upon continued exposure to air because it reacts with gases in air to form new compounds. This is a chemical change, okay? And chemical change results in a completely new substance. Okay? And as an example, burning is a chemical change. So if I have, for instance, methane and I burn it, I'll be having carbon dioxide and water, completely new substances. So that's why that is a chemical change. If you have one or two substances and they turn into, one or two or three or more substances, if you have some substances and they, react with each other and then they produce new substances, that would be a chemical change. But if you have like the same substance, that would be a physical change. Does that make sense? Questions? Okay. Law of conservation of mass. We talked about law of conservation of mass before. Can anyone tell me what was law of conservation of mass? Anyone?
Mass can't be lost or,
It can't be lost or added to the world. Everything is already here. Like, it can only change between forms. Okay, and what did you want to say?
I was just going to say matter can't be created or destroyed.
Exactly. So all of these things are like the same. They're paraphrasing one another, right? So if you have, like, basically matter is not created nor destroyed, right? So matter just be converted from one form to the other. So whether we have like physical change or like chemical change. So if I have like some water here and I come back, like in a cup I have like a little water, and then I come back like 3 days after, and then I see there is no water. So it didn't actually disappear, it evaporated, right? And went, from like liquid phase to gas phase. And also if I have a chemical reaction, if I have like some wood and I burn it and then, I see ashes or like it produces carbon dioxide, so it's a chemical change, some substances converted to the other, but they didn't disappear, okay? So this is basically law of conservation of mass. Whether the changes in matter are chemical or physical, matter is always conserved. In a chemical change, the masses of matter undergoing the chemical change must equal the sum of masses of matter resulting from the chemical change. Again, if you have some matter and then they go through some chemical change, if you have the masses of elements in your reactants should be the same as products. And in chapter 7 we're going to talk about like reactions. So the terminology that you don't quite understand, we're going to talk more about them. Don't worry about them. Or like what your friend said, matter is neither created nor destroyed in a chemical reaction. And, with the next slide, I'm going to kind of review them later too. But as of right now, any questions? Good. So far we talked about matter. And as you notice, chapter 3 is matter and energy. So now we want to talk about energy. So can anyone tell me what is energy? When we say energy, what do we mean? Yes?
The ability to do work.
Exactly. So we call the ability to do work energy. And matter is one of the two major components of our universe. The other major component is energy, the ability to do work. And does anyone know what is the definition of energy? Or like work rather. Yes?
Is it the release of heat?
So release of heat can be, a form, some sort of energy, yes. But when we say work, can anyone tell me, did anyone here pass physics in high school or like here? Nobody had a physics course? Okay. Do you remember what is work?
I know there was an equation, but I don't remember it off the top of my head.
Yes.
And I'm going off the top of my head right now, but isn't it the force of pushing at something and something to? It's something along those lines. I can't remember.
Yes. So basically, I had a teacher in our middle school that she was always saying that, the translation is that Newton multiplied by meter is joule. And joule is one of the units of energy or work. Newton is like unit of force or like, And then meter, Newton, then here, joule. And here is like length. If I can manage to write this. Okay, so in general, if I have an object here, probably I cannot move this one. But if I have like an object, right, and then I exert some force to it, and if it moves, I did some work. So basically, if I have the force being exerted on an object, and then it moves, if I have a movement, I did work. So here, if I exert some force to this, table, and it doesn't move, although I'm getting tired, right? But I didn't do any work because it didn't move. Okay? So in general, the work is defined as the result of force acting on a distance. For example, if you push a book across a desk, you have done work. So if I just push this and it moves, I have done some work. But if I just push this and it doesn't move, I didn't do any work. So I'm just going to ask you about this sentence here, so you don't have to worry about the equation. But it's good to remember that if you have some force, and as a result of that force you have movement, or you'll be having work, or you have done work. Is that clear? Questions? Okay, Now we want to talk about law of conservation of energy. Based on law of conservation of mass, can anyone tell me the equivalent of law of conservation of energy? So hopefully you guys now know the law of conservation of mass, right? So based on that, what would be law of conservation of energy?
Energy can't be created nor destroyed.
Exactly. So we also have like matter, energy is conserved, and the law of conservation of energy states that energy is neither created nor destroyed. The total amount of energy is constant. Energy can change from one form to another or transferred from one object to another, but it cannot be created out of nothing, and it does not vanish into nothing. Okay? Is that clear? You know, I remember like one of the traditional examples is like the chemical energy of your fuel, right? It has like chemical energy, and when the car operates, that chemical energy turns into mechanical energy, right? But it's not like, it doesn't disappear, or it doesn't come out of nowhere, right? So energy can be converted from one form to the other, but it doesn't generate or disappears out of nowhere. Does that make sense? Good. And here again, I wrote everything from your book in this slide, so you have all the information for your quiz and homework assignments. So virtually all samples of matter have energy. The total energy of a sample of matter is the sum of its kinetic energy, the energy associated with its motion, and its potential energy, the energy associated with its position or composition. So we have like a potential energy. So as we said, some of the fuels or all matter, they have like some energy associated with their composition, and also we have like energy associated with the position of the objects. So anything that has elevation, it has like a potential energy. Okay? Does that make sense? And it's kind of due to gravity that it has, like, because everything on Earth has a mass, and as a result it has a weight because of the gravitational force. They have because of their position of the objects and because of the force of their weights, basically they have potential energy. And every object that is in motion, they have kinetic energy. And if you pass or if you ever pass or take a physics course, you have equations for these and kind of more explanation. But for our course, just knowing these sentences is enough. Okay? And since I'm getting close to the end of the lecture and I want to make sure that we do the attendance, I just straightly go to the attendance slide. So just do the attendance right now, and if you have difficulties, just raise your hand. But I encourage you to try to make the link work if you can, because sometimes I write the attendance. I write them all on the class list that I have. So but to make sure that I have them documented online, I feel like it's more efficient if you can just fill them out right now. I appreciate it. But if you can't make them work, then just raise your hand and I come to you.